With plans to eventually colonize Mars, the development of SpaceX's Starship has been making headlines over the past 2 years. One of the main questions people have asked is how much it will cost to send each Starship into orbit in future years. Just like past targets, SpaceX has set an ambitious goal to bring its Starship to production at a combined launch and operational cost of just $2 million. That's just over 16 high-end Teslas, or 1.3% of the average NASA launch, which sits at a whopping $152 million. So, without further ado, how exactly does Musk plan to reach sub-$2 million Starship launches? Well, it's a little complicated. And of course, it would be. We're talking about cutting average launch costs by upwards of 99%, and that's no small task. Nonetheless, SpaceX and Musk have a few tricks up their sleeves, starting with methalox. For those of you not too familiar with methalox, it's SpaceX's latest form of fuel. The fuel is a considerable cost-cutting measure consisting of a liquid methane and liquid oxygen, or LOX, mixture. Of course, methalox offers additional benefits in higher efficiency, easier production, and vast availability. Some estimates put a price for a kilogram of the substance at bulk on 20 cents, while others say upwards of $10. Still, it's much cheaper than the usual rocket fuel suspect, RP-1. According to some estimates, Rocket Propellant 1, sold privately, retails for roughly $50 per pound, or about $23 per kilogram. However, methalox is 20% better performing, making RP-1's comparable price $27 per kilogram. Again, RP-1 prices are private, and therefore semi-unknown, although the relatively high price makes sense. Kerosene has become an increasingly minor part of the world's fuel economy, and it's become harder to find a producer and RP-1 manufacturer. As such, SpaceX completely ignored the fuel, choosing methalox and its hopeful price of roughly $10 per kilogram. Thus, at an immediate and adjusted discount of approximately $13 and $17 per kilogram respectively, SpaceX stands to spend much less on fuel than previous launch vehicles. Plus, at a $1.4 million fuel price tag, NASA's usual RP-1 budget for a single external tank is a bit higher than Starship's methalox option for the entire Starship vehicle. Musk and SpaceX plan for flights with just $900,000 spent on fuel. That's incredible, especially considering the Super Heavy booster stage will hold a whopping 3,400 tons of fuel, with a price less than 65% of the average. For reference, the Space Shuttle had just 2,000 tons of fuel across 2 solid rocket boosters and an additional external tank. So while this is still in the works, SpaceX already plans for Starship's launches to have booster fuel at a cost 2/3 the price of and capacity 1.7 times the Space Shuttle's total. That's even ignoring the benefits of methalox with the namesake Starship second stage. Speaking of which, here's a transition to the second potential cost-saving method: manufacturing. Currently, humans, by hand, build and test spaceships. It's a prolonged and expensive process. Again, if we use the Space Shuttle as an example, you're looking at an estimated 5 years from construction, start to finish. Of course, there's the apparent expense in the form of paying hundreds, if not thousands, of engineers and welders for 5 years of work, although that's not all. But then, think of all the costly mistakes, the inability to build another spacecraft while this happens, and everything else that slows down the process. It's painstakingly long and expensive. So that's why SpaceX is going the direct-to-manufacturing route. And yes, the Space Shuttle and other spacecraft had been manufactured partially, although generally in the form of parts and materials. Not SpaceX. Well, yes, SpaceX too, but also including actual aspects. Starship, currently manufactured in parts at Starbase, is a shining example. By March 2020, over 500 people worked at the site, with most producing Starships. Although reports put it at thousands, there's not much information on how many worked on physically building the Space Shuttle. So, compared to other spacecraft productions, Starship's manufacturing method involves fewer people, higher quality full-scale prototypes, faster construction times, and shifts set up to produce parts and tasks continuously. It's honestly quite impressive how well Elon Musk and the management team at SpaceX have managed to iron out a process that hadn't existed beforehand. Well, manufacturing has existed, but it hasn't at the scale and the speed at which SpaceX wants Starships. Additionally, we haven't been this close to automating spacecraft production as we are now. Well, it's not that far, but it's much closer than we've ever been. And if we reach autonomous spacecraft production, the cost synergies are incredibly high. Think about it. SpaceX will no longer have to A. Pay for manual labor, B. Pay extra to have the best engineers and contractors out there, C. Pay even more thanks to the long process of building a spacecraft, and D. Save money on a lack of failed prototypes or engineering errors. After all, SpaceX is likely the closest company we have right now to autonomous spacecraft production capabilities. And knowing Musk, he'll have it within the decade. However, automated spacecraft manufacturing and the like still isn't as impressive as the cost savings Musk can achieve through Starship's most significant benefit: reusability. While reusability is one of Starship's most exciting qualities, people frequently underestimate just what it can do. Sure, you have less waste, often higher quality and more, although that's not really where the cost drops kick in. The actual drop is obviously in SpaceX not producing another Starship every time they need to send one to space. But even still, it's more than just the cost of materials. Of course, the company expects to save a lot just by reusing a Starship. Estimates put a Starship at 4 times the price tag of the $62 million Falcon 9 rocket. So you're looking at a cost savings of at least $248 million in not just building another Starship. The current Falcon 9 breaks even on costs after 2 to 3 launches. That's a $62 million partly reusable vehicle. SpaceX expects to reach a much lower price point with Starship, but in a fully reusable package. So you face lower upfront production costs and have a higher reusability and lower long-term expenses. However, reusability serves SpaceX with more than lower material, labor, and production costs. With a fully reusable vehicle, SpaceX can create more Starships without having to retire previous ones. I don't know whether that seems confusing at first, so here's an example. Let's say the Starship wasn't reusable for some reason, and SpaceX loses a booster or another essential portion with every launch. So if you were SpaceX and you wanted to have 25 Starships available for launch by the end of the year, you'd have to construct 2 boosters for every Starship that launches. As you're losing a booster with every launch, production capabilities and output will also increase. That's expensive. NASA spent around $500 million constructing a facility to produce a space shuttle in 5 years. Now, if you need to build 2 boosters or entire Starships for each one you launch, you'd have to increase production, grow the size of a production facility, hire more staff, and everything unfolds in price. However, by reusing Starship, $216 million in pure material and labor costs are skipped. That's without considering the hundreds of millions that SpaceX would save in not constructing additional factories and increasing production. If SpaceX is already spending millions on producing a fully reusable spacecraft, imagine what exponential increase in output would result from every vehicle you make. So, with these 3 cost-saving factors, SpaceX can save money on fuel, manufacturing costs, material costs, expansion prices, labor costs, land purchases, lost vehicles, potential environmental fees, and more. So even if Starship doesn't manage to reach the $2 million launch mark, they'll be much closer than any other vehicle out there. Even still, there's no guarantee that these cuts will be enough to get Starship below $2 million per launch, or even close whatsoever. The Falcon 9, for example, is a much simpler, partially reusable vehicle, costing $62 million to produce. That's 31 times what Musk has planned for Starship, and it's for a considerably cheaper product. Still, Falcon 9 uses less efficient Merlin engines, running on the less efficient RP-1 fuel, and is only partially reusable. So these aren't exceedingly comparable options, although they're likely the best SpaceX-centric options we have. Nonetheless, the average NASA launch costs $152 million, for a total of 6,400 kilograms at $23,750 per kilogram. So if Starship barely falls beneath, say, $50 million per launch, at a payload capacity of 100,000 kilograms, SpaceX will still produce cost savings of 98% per kilogram of payload in total. So, now knowing this, what do you all think? Can SpaceX eventually make its way to the $2 million launch cost? Or will they be stuck in the tens of millions? Do you think concepts of $2 million per launch will ruin reception to, say, a $25 or $50 million launch? Even with cost savings per kilogram in the tens of thousands, the hype might be too high, currently, to settle for a potentially higher price. So let us know what you think in the comments below, and make sure to like, comment, and subscribe if you want to see more space videos like this one.